Hi everyone. I'm going to go ahead and go over the second quarter extra credit that I gave out on Friday. If you are turning this in, it has to be turned in on Monday. No date past that. So during your class time on Monday. Okay, so we're going to be talking about increasing and decreasing intervals on when a graph is positive and when a graph is negative. That's two different parts there. Part A is just the increasing and decreasing intervals. We're going to do that part first on all three graphs. Okay, then we're going to be looking at what's called set builder notation on how to write this with the smallest value and then the largest value. Okay, so we have to understand though, first and foremost, we are only considering X. Nothing to do with Y for these examples, okay? So we're going to be looking at this graph. Before I get started, I want to talk about where I'm going to be finding these X values. So let's pick up this first graph. Now, this graph here, these little boxes are representations of arrows. An arrow means that this graph goes on or actually started from this direction way over here. It is called a linear graph, which means it makes a straight line. It also goes off to the right forever and ever and ever in that same direction. Okay. So when I'm looking for the X values of the graph, I'm just going to pick a point somewhere on the graph, not the coordinate plane, but on the graph. The X value here would be -3. The X value here would be -1. The X value on the Y-axis would be 0. The X value here would have been +3. The X value here would be +5. The graph doesn't stop there. It continues. What would the X value be here? What would the X value be here? How about here? So eventually this X value keeps getting bigger and bigger the further and further it goes to the right. So the X value all the way to the right is known as positive infinity. It is a number we have yet to count to. All right, so then on the other direction though, as it's going to the left, we see it went from -1 to -2. The X value here is -5. Although that is where our coordinate plane stops, our graph does not stop there. Our graph continues to the left, and the X value at that point over here is known as -infinity. So X equals -infinity. And over here, it's X equals +infinity. Okay, so we are going to be looking at those values, the furthest left and the furthest to the right. The furthest left is the smallest one, the furthest to the right is the largest one. So when is something increasing? It is increasing between which two numbers? Smallest number on the left, largest number on the right. This is called set builder notation. Okay? It is a set that builds up from the left to the right. Decreasing. This graph never goes down. It is never decreasing. So for decreasing, we can put does not exist. You can put never. Does not exist, not does it exist. You can just put doesn't decrease. Talking and writing is my talent. Okay, so does not exist. Now another way that we could write that it's increasing, we could also just do this. We could say it was increasing all the way from -infinity to +infinity. So we could say all real numbers. Or always. Abbreviate that, ARN. Okay. When does this one decrease? It doesn't. So we could put it does not exist for decreasing. Remember, because we're reading from the left to the right. As we look from the left to the right, this graph never goes down. Okay? All right, let's go do the increasing and decreasing on the other graphs, and then we'll come back and do positive and negative on each of the graphs. Okay? So let's go down to this graph here. This graph here is called a parabola, and it goes along with our quadratic functions, which we'll talk about later this year. So again, reading the graph from left to right, okay, I had something here that I don't want to see yet. So when I'm looking at this here, this graph on the left side of the graph, or as it starts, This is all called increasing because the graph is going up, so that's increasing. Right there, it stops and it turns around. That is called a turning point. That turning point is where x equals 1. Okay, that's going to be important to us on this one. Okay, we're not looking at the y values today, just the x values. After the turning point happens, the graph decides to start decreasing. And it's going to keep decreasing the further right that it goes. Okay? It would keep going, and it would keep going if it could. Okay? So it's going to keep going, and it's going to go how far to the right? As the x values go from 1, 2, 3, 4, 5, the x values over here are going to go all the way to positive infinity. So over here, x is going to equal positive infinity. Or you could also write positive infinity. Okay? So on the left side, the opposite side of it, over here it wasn't positive infinity. It actually started where x equaled negative infinity. Okay? Or you could write it as negative infinity. Okay? So my question is then, when was this graph increasing? It was increasing when x was between which two numbers? Well, the smallest x value where it was increasing was negative infinity. When did it stop increasing? When did it stop rising? That was when x equals 1 at that turning point. Okay? So when was it decreasing? Well, it was decreasing. It started decreasing just after the turning point, so where x equals 1. And it continued decreasing forever and ever. So that is where x equals positive infinity. All right? Now another way that we could write this, we could say it was increasing when x was less than 1. And it was decreasing when x was greater than 1. Okay? All right, let's go look at our third graph and find out when it was increasing and decreasing. So on this graph here, when was the graph increasing? I've already done all the highlights. I've already noted the turning point, and I've already listed the x values on the left and to the right. Okay, so when was it increasing? Between which two numbers? And then when was it decreasing? Right? So this one here started increasing when x was 1, or just after x was 1. Should say just after when x was 1. And it continued to increase all the way until we get to positive infinity, wherever that may be. Okay. When was it decreasing? Well, it started decreasing at negative infinity, and it continued to decrease until x approached, or until x was close to 1. At 1 is where that turning point was. Okay? Another way we could say this, it was increasing when x values are greater than 1. It was decreasing when x values are less than 1. All right, so now what we're going to do is we're going to go back through all three of those graphs again, and we're going to fill in the positive and negative values. So this would have been a separate question. Okay, so let's go back up here and talk about when is it positive, when is it negative. So a graph is positive when it is above the x-axis, and a graph is negative when it is below the x-axis. Right? So when is this graph positive? Between which two x values was it above the x-axis? Well, it started to be above the x-axis right here. And it was always above the x-axis all the way up here. So the smallest x value would have been negative 5 all the way to positive infinity. So when was it below the x-axis? Well, it started being below the x-axis somewhere way over here. And it stopped being below the x-axis right here. That's when it crossed over and then started becoming above, so that would make it the positive side. So it started at negative infinity all the way up to just before -5. Okay. Now, this is the interval notation that you'll see me in class. I'm going to focus on. If you have any questions as to why I choose to use this, let me know. And then we're going to talk about how else it can be noted. Same thing here, but it's still called interval note. Sorry. It is still called, and I have it up here. It is still called that set builder notation, not interval. Sorry if I said that anywhere along the way. Set builder notation, but it is written when it was positive when x was greater than -5, and it was negative when x was less than -5. Okay. All right, let's go on to do positive and negative of the second graph. So here, if we have this graph, and I said, when is it positive? When is it negative? Positive is above the x-axis. Negative is below the x-axis. So when was it positive? It was positive from -1 to 3. Okay. So it was positive when x is between -1 and 3. When is it negative? It was negative between -infinity to -1. And, oops, I totally messed that one up. Let me fix that. -infinity to -1. And it is also negative from 3 all the way down. It's negative, but from 3 all the way to the right to positive infinity. So, and from 3 all the way to positive infinity in x values. So it was positive between -1 and 3, and it was negative when x is less than -1 and when x is greater than 3. Again, in class, I will be focusing on writing it this way. Okay? There are connections. If you have questions, ask me and we'll look at those. All right, let's look at our last graph for when is it positive or when is it negative. Okay? So on this one here, if I'm looking at it, I'm like, okay, when is this positive? When is this negative? Again, positive is above the x-axis. So this graph is always above the x-axis. When is it below the x-axis? It isn't. It always sits above, which means it's always going to be positive. So it is positive always. Or we can write that as all real numbers. X is positive always between -infinity and when x is positive infinity. It is always above the x-axis. When is it negative? Never. It's never below the x-axis. So we can write D N E for does not exist. Okay? So you have 3 examples on the back side of this that I want you guys to try. And there's even one extra if you wanted to try to make your own graph and see if you could identify that positive and negative and increasing and decreasing values given x.